All right, the amplitude is 2 centimeters, but then we have to change it to meters. So 0.02 meters, and the mass is 50 grams. We should also change it to a 0.05 kilograms. Okay, and period, as we said in previous problem, is 2 pi over b. So therefore, you can leave it as 2 pi over 10 or pi over 5. The way it's fine. Okay, in seconds, of course. The spring constant, because we know our period, which is pi over 5 seconds, we can use the period equation, which is what? Mass over K, and we have the mass. So 2 pi over 10 is equal to 2 pi, and then 0.05 kilograms over K. 2 pi got canceled out. So it's basically 1 over 100. And then 0.05 over K. So K is equal to 5. 100 times 0.05. So yeah, I kept the 2 pi over 10 instead of pi over 5 because the 2 pi could be canceled out really nicely. Okay, all right, so that's part C. Because that's what we had for the period, right? 2 pi over 10. That's 10 is a b value. So instead of simplifying it and put the simplified version on the left-hand side, I just kept the original 2 pi over 10 because I can cancel the 2 pi on both sides immediately. So the next step I can do after canceling out 2 pi on both sides is to square. M over K. What's that? M over K. M is 0.05 kilograms. 5 newtons per meter, a unit. Okay, all right. So with the spring constant, we can now calculate the total energy because we can calculate the elastic potential energy. So 1/2, 5 newtons per meter. And the compression is simply 0.02 meters. Okay, square. So 0.5 times 5 times 0.02 square. And that would be a really tiny amount of energy, which is 0.001 joules. Okay. Yeah, it's small. When the object is small, the compression is also very small. So that's why the energy is really small. It's just like how much energy is stored at your pen right now or pencil right now if you have a spring inside the pen. So won't be too much. And the maximum speed, as we said earlier, the spring potential energy, elastic potential energy will be converted to kinetic. So we simply substitute in the 0.001 joules from the previous calculation, and then we have 1/2 mv squared, and we have the mass, and we have to find out the v. So simple math right there. 0.001 times 2 divided by 0.05, and then square root that or raise to the 1/2 power. So the velocity is going to be simply 0.2 meters per second. Okay, 0.2 meters per second. Now part F is the challenge right here. Okay, so we're saying, hey, Diagram, your math is pretty good. So what if I want to ask you, what's the velocity at 4 seconds? 0.4 seconds, right? 0.4 seconds. What's the velocity at the time? What can we do to find out the velocity at that time? Okay. The reference chart is not going to help you out in that case. Not kinematics. Something easier. You are going to use the function that they gave you. Because if you know the time, you actually know where it is at that very moment. So we are going to use the equation, x of t equation, but then I'm going to go ahead and change the 2 centimeters to 0.02 meters, cosine of 0.4, 10 times 0.4, which is simply 4. Now, but be careful on one thing, that is this part right here. You do not see any degree symbol. That means it must be in radians. So when you do your calculation, make sure you double check that it is in radian mode, or else you will get some funky answers. Okay, so on your calculator, you can go to mode, which is on the left upper corner, and then you can go ahead and select radian and enter, and then you can go second mode. And you can go back. All right, so you go ahead and do that, and let me go ahead and do it on my calculator as well. So new calculator, and 0.02 times cosine of 4. Make sure it's in radian mode. Yes, it is. So it's negative 0.013. So negative 0.013 meters. Oh, rearrange the equation? Well, I just substituted the 0.4 in the t. Yeah, that's what the function means, right? So now, what does that mean? That means if you have the spring, and this is 0 meters, so the ball is actually where? The ball is actually somewhere here, okay? Because it could go all the way to 0.02, but it's 0.013, so like 1.3 centimeters to the left of it, okay? So what's the velocity? What's the velocity? Now, so what are we trying to do here is to acknowledge one simple understanding. That is, this object right here, it is not right in the middle. It's not at the end of it. So it possesses both elastic and kinetic energy. So it has, I mean, in the middle, at the end of it, we have the total mechanical energy, which is the elastic energy, elastic potential energy. But then right now, it has both elastic and kinetic. So we have to take that into account. So 0.001 joules, right? It's what we had for the total. So now we have to make sure that we have the right position, which we do now. And 1/2 K x square plus 1/2 m v square. So you're looking for v right here. Okay, you're looking for v right here. So so I'm not gonna rush. So just do it one by one. 0.013 square times 5 divided by 2 it's going to be a pretty tiny number, 0.0004225, and then 0.05 divided by 2, it's 0.025 v squared. So you subtract the really tiny number to the left-hand side. To the left, yeah, minus 0.0004225, and then you divide it by 0.025. So v squared, it's equal to 0.0231. Make sure you get that number. So we take the square root of this number. So our velocity will be at 0.15 meters per second. And that is something I would say, yeah. As you can see, it is still the what? The conservation of energy. The law of conservation of energy right here. So that's why even though the equation, the pendulum and spring equation, the application of it is just 4 to 6% on the AP exam, but then it could relate to all the other major concepts. So that's what you need to look out for.